In recent years, new mobile devices such as the Apple iPhone, BlackBerry Storm, and Google Android have packed functionality such as GPS, internet browsing, and email into ever smaller packages. As a consequence, these devices are becoming more and more part of our everyday life. Carlson et al. Note the ever-increasing trend for users to interact with these devices with just one hand. However, interaction with a device in one hand poses a number of challenges. Since the user is using their thumb, the problem is that their thumb is going to block very large areas of the screen, and that makes it very difficult to know what they're pointing at, what's underneath their thumb. The sheer size of the user's thumb compared to a traditional stylus makes it very difficult for a user to know what part of their thumb is acting as the contact point on the screen. And of course, the thumb isn't exactly a very mobile digit, and it's very difficult for a user to reach the edges of the screen. Previous work with one-handed mobile operation in this manner has tended to focus on the selection of single on-screen targets. Our work focuses on the problem of facilitating the selection of multiple on-screen targets by a device user. For example, suppose a user is using a mobile mapping application. They search for restaurants in the area, and then they want to select a few nearby to them to compare. Some other examples include selecting a group of pictures to send to nearby mobile devices, playing a game, or selecting recipients of a text message. There are any number of other possible examples we can come up with. There's clearly a need for techniques to support this style of interaction in this case. We have developed two such techniques, burst and zoom tap, and we compare them to the existing shift technique, which was designed for one-handed single target selection. Our experimental task presents a user with a map with various on-screen targets. These targets could represent anything such as hotels, restaurants, or museums. In each trial, the user is responsible for selecting the red targets. These red targets are meant to represent a subset of the targets that a user wishes to compare, for example, restaurants near their current location. Burst works by creating proxy copies of the targets that are occluded by the thumb and placing them in an arc around the thumb. The user touches the screen to activate the technique. Copies of the targets are created and placed around the thumb in an arc. The user slides their thumb across the targets to activate them. Releasing completes the task. The zoom tap technique makes selecting targets easier by providing a zoomed view of the screen. The user simply taps on the screen in the area they would like to provide a zoom view for. The zoom view remains while the user toggles targets with their thumb. The user can turn targets on and turn them off as they see fit. The user can dismiss the zoomed area by tapping outside of it. While the zoomed area is activated, the user can also use gestures on the screen to change the focus of the zoom. The shift technique works by creating a callout above the user's thumb containing a copy of the occluded area. The user touches on the screen to activate the technique. Crosshairs in the center of the callout indicate the area that the user is currently pointing at. The user releases their thumb to complete the selection. Our results show that both burst and zoom tap result in faster selection times compared to shift. In addition, both burst and zoom tap result in less selection errors as compared to shift. Finally, the results of a participant survey show that burst and zoom tap were generally preferred over the shift technique. Through participant feedback, we've identified a number of potential improvements to the current design of burst, which we plan to evaluate. We also plan to evaluate burst and zoom tap with overlapping targets.